go. I lose my notes, so if I get a little off topic, then
Just get to him, get to the count.
Firstly, apologies for starting a little bit late. Should have foreseen technology issues. The purpose of this stuff is JavaScript craftsmanship. It's not an oxymoron. We can be craftsmen in JavaScript. JavaScript's a perfectly good language for doing what we want to do. Now, basically, craftsmanship is important in code. The more time, we spend a lot more time when we're maintaining code than when we're building it in the first place. So personally, I'm a lot less interested in rapid development. I'm more interested in building something that's easy to maintain. So what I'm going to try and do is go through this with kind of what JavaScript does, the things to watch out for, but also how to not leave a problem for the next person to come and find. One important thing, people tend to start using JavaScript rather than learning JavaScript. And that's often where a lot of the problems come from, is you start using a language, it does something you don't expect, and you just blame the language. Actually, sometimes you need to learn to blame yourself. So we've got varying amounts of JavaScript experience in here. I'm going to start with the basics. If you've got any questions, however stupid they sound, feel free to ask. I've basically been going through this trying to work out what things I've assumed, what things I've never asked about. And actually, as I've gone through this, there's been some things I've had to go into the console and really figure out how it does behave, rather than just what I think the answer would be. Now, one thing here, JavaScript is a bit of a special case. This book here is JavaScript, the Definitive Guide. This one's JavaScript, the Good Parts. There are a lot of things in JavaScript you don't want to play with, and part of the craftsmanship of JavaScript is playing with the bits that are good and not playing with the bits that are bad. The other thing is, if you think that I've missed something, if you think that there's a step of logic that I've just assumed is there, feel free to jump in. I'm sure there's some things that I'm taking for granted. These would appear one by one, so try not to get ahead, try not to get swamped by their things too much. Defining leaves things undefined. JavaScript's a bit weird. If you go, one of the things, sorry, just before we get into that depth, one thing I have jumped over. If you want a playground for JavaScript, go into Chrome or any other modern browser, go to About Blank, and you'll get a completely blank website. If you go to console, then you've now got a kind of a space in JavaScript where you can just start doing things. So if I look for window.mat, window.mat is undefined. Okay. So if I now window.mat a window.mat a, so we've got a little space we can play around with. One of the things that you find in here is defining things leaves them undefined. So actually, if I jump back into my console, right. So I've got ABC. ABC is not defined. So if I define ABC, and now look for the value of ABC, the word undefined here confuses some people. I've just defined it. Why the hell is it undefined? And the reason is that undefined it's not got a value assigned to it yet. So that's just one of the many little things that we kind of have to get past in JavaScript. Defining things leaves them undefined. Arrays an object. Okay. When you're defining things, you might. Come on. Lost my console now. Sorry. When you're defining things, you might come across one person who's creating an array here, and another person that's creating an object. Dealing with them in very similar ways. And you might not be sure which one's the right one to go with, and we'll dig into that a bit later. But arrays and objects are remarkably similar and annoyingly different in JavaScript. So that's just one of the things to watch out for. Overloaded plus and nan. basically, another thing to watch out for is because you've got 1 plus 1 is 2, and A plus B is AB, you get some weird cases. So basically, I can, so I've got examples of these. Things like, if you get to a point where, because JavaScript's typing is dynamic, but it's definitely there. There's definitely a difference between 1 and 1. There's a big difference. The difference is, if you go, we just create a variable, A is 1, we go A plus 1, we get 2. We define that as a string of 1, and then we rerun A plus 1, we get 11. 1, 1. So there's a weirdness here that you get to when you deal with the concatenation mixing with the with the addition because of the overloaded plus. Sorry, just to clarify, I'm looking to run through these quickly and then come back and explain in more detail how we should be doing these. This is a list of warnings more than anything else. Nan. Have you ever done something in JavaScript and come out with nan? N-A-N, not a number. It can be a lot of fun, and I've got some lovely examples of how annoying it can be in some work. So if we've got, so A times 2, currently A is a string and it doesn't complain, but if A becomes undefined, and we rerun that, we get nan. The biggest problem with nan is that it's infectious. Any maths that includes nan, any maths that includes nan completely breaks things. So at this point, B is nan. So I can do 10 times 4 times 3, times 2, and get that. But if I do at any point, change that in, we get nan. The most annoying thing about nan, if you ask, is nan nan, the answer is no. So you have to go off and specifically look for, is it nan? And then you find out. So there's these sort of things that can just creep up on you, and you get down this route. It's just painful. One of the things I think causes people unnecessary confusion is equals, double equals, and triple equals. So equals doesn't equal equals. Basically, have you ever come across code that's like, so I just set A to 1, and if A is true, so dog. So we've got there, we've set A to 1, and now it suddenly equals true. There's a thing going on here called type coercion. Type coercion can be really useful, can be really dangerous. The dangers, I think, are a lot more dangerous than the useful is useful. If you stick a third equals in there, you don't get that found console off. And the reason is A doesn't exactly equal true. Without type coercion, without turning a 1 into a true, it doesn't match. So the simple version of this, and I'm perfectly happy to come back to it later, but the simple version here is always use triple equals. If you always use triple equals, it will behave correctly. Now, one thing that might be a surprise here after seeing that is that JavaScript does have instance equality. So if I've got A as an object and B as an object, and I go A equals B, then we'll get false. Whether we use 2 equals or 1 equals, we'll still get false. Both versions will do instance equality, not value equality. Do we know what that means? Yeah? So two different instances that look the same are still different. So I think people get confused when they see a double equals and think that it's a kind of loose equals and it's going to behave more loosely than it actually does. Generally, if we stick to 3 equals, we all know where we stand. The other one is not equals, the strict version of not equals. Looks like that. On the other hand, we've got single quotes and double quotes. In some languages, those are different. In others, they're not. JavaScript's one of those where single quotes and double quotes are exactly the same. There's no difference. There's no variables that come in. There's no difference whatsoever between single quotes and double quotes. Now, one of the things that comes in, the guy who wrote this book, the JavaScript Good Parts, has written a tool called JSLint, and what it does is it goes through the code. It's like check style in Java, like Ruby with Ruby. It goes through and makes sure that you're using the language in a sensible way. So basically what he's saying is there's some things that you should never ever do. And one of the things on his list is using double equals. So you can have that to literally go through your code and go, any time you use double equals, it's wrong. So whether we're using that or not, it's probably best when we're writing new code to always use the triple, because it's safer. Now, there's an even stricter version that goes through and makes sure you always use single quotes. The only reason for that is to avoid confusion. There's no difference at all. One of the problems I have with JavaScript out of the box is that it's missing some really important, useful functions. When you get to kind of this style of language, you often get some really useful things thrown in, and JavaScript seems to be missing a lot of the useful things that are thrown in. So one of the things we're going to look at in detail later is adding things like a starts with and ends with function to string and an iterator to loop to arrays. Because JavaScript's very flexible, we can build that stuff on top. So we don't need to be limited by those kind of missing functions. One of the biggest dangers is global scope. Now, in the console over here, if I set A is true, and then later on I go if A console log, I just bound. Get that. Someone else comes in somewhere else. There's a function which is do something, and what that does is sets A to false. As a side effect of what it does, and then we come back and run our expression again. It's suddenly changed. Now, some languages don't actually give you a global scope at all. Some languages kind of make it difficult to use it, but JavaScript is far too simple to use global scope. So we're going to look in more detail at how to contain scope. And that's probably about half of what we're going to look at today is how to contain scope. But the big thing is you are able to write anything you want into global scope, and some people use that too freely. So essentially, my argument in any language is that the scope of something should be the absolute minimum that will work with the current version of the application. For that reason, I get told off for writing lots of private inner classes inside Java, that sort of thing. I'll write a private util instead of a public util. I'll really try and keep it low. The main experience, bad experiences that have taken me to that point are when you're using kind of global scope of JavaScript. It's just been so painful to not work with. Now, I've worked with a lot of code bases where things like this happen. You've got a function, I don't know, next slide, or I have one where it was move right, move left, and then suddenly something else comes in, it's got that behavior, and it's already in global scope. So you end up with a kind of namespacing thing, where you've got kind of function, and it's going to be, I don't know, my widget, something, something, whatever, next slide. And you end up with these big names that are trying to, the name of the function is trying to do too much, and that's another symptom that we're playing with global scope too much. The general thing is, we want a very small footprint on a global scope. And we'll go through a few ways that we can do that later. The biggest thing that confuses people in JavaScript is that functions are first-class objects. functions are really, really powerful, and you'll see them used a lot throughout this. Kind of, the functions are your way of containing scope. They are your equivalent of classes. They're also your equivalent of methods. You call back something to do all sorts of powerful things with them. And it's worth really understanding how functions work. That very quick overview is that. I hope that some of those things sound familiar. Some of those things are problems that you've seen before. And hopefully we'll now go through in more detail with a few of those. Are there any questions at this stage? Okay. So, a little craftsmanship interlude. Immutability is next to godliness. If something shouldn't change, we shouldn't let it change. And I know I've seen some code where developers have gone blindly through, create an object, and then create all the getters and setters. I've sat next to them and they pressed the create getters and setters button. I'm like, why are you doing that? You're giving people more control than they should have. And there's a big danger that in JavaScript we do that by accident, not by design. So what we're going to do is go through this. I forgot to actually compile it. I think this is valid Java. Creating a person. Now in Java we've got all the constructs here, private, final. So we've got a person with an age, and you can get it, but you can't set it. So whether or not the Java's actually correct, does that concept make sense? When we create it, we get the person a name and age. If anything changes, if I decide to change my name, then we need to create a new person to represent that. That's the whole purpose of immutability. Now, if you sit down and just kind of write that equivalent in JavaScript, what you might come out with is this. If you ignore those warnings on the right-hand side for a minute, you create a function called person. Now, this one's got a capital P to say that it's an object. It's more of a class. It takes a name and an age, and then it assigns internally this .name is whatever name you gave, and this .age is whatever age you gave. Then this is where it gets kind of JavaScript-y. Person.prototype.getName. When we created person, there's now a prototype there, and we can affect what's on that prototype. So we can say, right, add a getName function to that. So this function here becomes getName, and we're going to return this .name, and then we're going to add a getAge function, which will return the age. Now, there's some bits of that, like the .prototype, that feel completely foreign, and there's some bits of it to Java developers particularly, or kind of more classically object-oriented developers, feel really at home with return this .name. It looks more like what they're expecting. But there are a couple of danger points with this. The big one I find is the immutability thing. So you create a person called Matt. Matt is 26. Now, then you go and change details about Matt. So I'm expecting my first child at the moment, and its affectionate name is Cedric until it's born, because it was a name that I was banned from giving it once it's born. So I'm using it as much as I can until it's born. So at the moment, Cedric's about minus 0.25, and he's got the name Cedric. So if I create a new person, call it Matt, and then change that person to be someone different, that's of course breaking the immutability. So what happens when we ask for the age? So let's actually run this. Drag that here. So we're creating a person, the equivalent of a class, and then we're going to create a new person. So now if we look at Matt, person, Matt, age 26, we then change this. So we set Matt's age and we set Matt's name. So now if we look up Matt, it's completely broken immutability, everything's changed. So when we ask for the age or ask for the name, let's just do a get name, Matt.get name, what we get back is Cedric. So actually that's just wrong. I would argue in any language, in any setting, that's just wrong. So whether or not you agree with my reason for not liking it, actually there are times when we want to protect against that one. The other big danger, sorry, here is to forget new.
Matt?
Yes?
Are you saying that that's wrong because the name of the person in the variable name is Matt, and the name in the value is Cedric. Is that why you're saying that's wrong?
I'm saying it's wrong because this code...
Because you have changed the name, and then you've gotten the name back that you've changed it to, so how's that wrong?
So it's wrong based on... Jump back to slides. On the immutability argument. That if we create a person, we shouldn't kind of repurpose that person, we should create a new one for something new. And what's happened here is that the way that we've laid it out in the Java class doesn't allow that control. The way that we've laid it out in JavaScript doesn't look like it allows that control. So essentially what I'm saying is there's a side effect to this, there's a danger to this, we're exposing the scope and we're letting people change things. We never intended them to change. If we wanted them to change it, we would have had a set name, set age. But without setting that, we've accidentally opened the door to all sorts of craziness that we never signed up for. Does that answer the question? Cool.
What you were about to say something about don't forget.
Yes.
New.
So new. If I come back into here and so if I'll just refresh the page and recreate that person. So now Matt is person. With Matt and 26. So here I've forgotten to put in new. If I now ask for Matt's age, we get a type error. The reason is when you run this without new, it just runs as a normal function. So it's going to go, this .name is whatever name it is, and this .age is whatever age. But it doesn't return anything, so it's returned undefined, essentially. The most dangerous thing here is if I now just say name, we've got a scope leakage. The window, the whole document now thinks it's called Matt. And so there's what happens there's a bit of magic with this. One concept I haven't dived into is that if I create variable A, which is equal to ABC, and I look on window.a, I've got that variable. If I set window.a to DEF, and now look at A, I've got that back again. Window is your global scope. So I forgot to mention that one. And what happens here is if you set it without new, this is the scope of whatever it's running in. So in this case, the window, in other cases, other objects or whatever. And you end up basically leaking the scope of what you're doing out to whatever parent scope there is. And in our case, it's gone all the way up to the global scope. So doing this without new is really dangerous. The good news, I have regular arguments with people, with JavaScript people over whether or not we should ever use new. I'm going to put forward the argument in this that we should never use new. We should never expect someone to use new. And I'll explain why as we go through. So the question is about how we contain these variables. So just a really quick lesson about functions for scoping. If I create a function called A, create a private variable called private variable, set it to private, and A will return I am private. Let's just run this. What's going to happen there? If I run A, we get I'm private. It will be exactly as you'd expect. And if you do a type of, if you look for whether that private variable is leaked or not, it hasn't leaked. So what we've done here is contain the scope of that variable by sticking it inside a function. If we had done the same thing, if I just redefine A, but without that bar, we get the same problem of scope leakage. So now if I run A and ask for the type of private variable, all of a sudden it's a string. If I look for the value of private variable, then we'll get private. So there's this really fine line about scoping, and we're going to go through it, but the big thing is, inside a function, if you use a var, it will be contained within that scope. So we're going to have a quick look at the contained version of that person object. Function generate person takes a name and an age. So again, if you ignore that bit, we'll come to that in a minute. What it does then is return two functions. Now this is essentially the kind of first step of containing scope in JavaScript. What we're doing here is we're not even setting this.name, this.age, there's no this, there's no new, there's no any of that. These inner functions can access anything that's in scope for the parent. So when we run that one and we do the same test here, and we go var mat is generate person, mat 26, then we look at mat. The public interface of mat is now completely different. The public interface is an object which has a get name and a get age. So we've not actually exposed that stuff publicly. That object is this one here that we've created. So if we look at the mat.getName, it's going to tell us mat. But if we try and maliciously change the name, so now if we look at mat, we've now got a name attribute on that. But when we ask to get the name back, we're always going to get mat. It's because the scope's contained. So this is. Sorry, this last one is if we did want to create a Cedric person with a different age, then we can create that person, we can get their name, we can do all of that stuff, but it becomes important there's two different names, they don't change for the life cycle of this application. So that's the first kind of step that I'm expecting a bit of a jump. I'm seeing some frowns, that's a good thing. That's a good thing at this stage. What questions have you got about that? What steps have I missed? What haven't I explained? Because there will be something.
Can I add something just to your previous point of using bars, which makes it even more important. Well, it's a kind of link actually. That's a sure way to build leaking memory leaking apps. Because if you define all the variables inside a function that you're going to use with var, then at the end of that function, the garbage collector knows to collect them when they disappear out of scope. And when they go into the global context, then they never collect.
So containing the scope not only helps us with immutability, helps us to know that we're not exposing things that we shouldn't be exposing, but it also helps garbage collection performance.
Yeah.
Anyone want to ask a stupid question about this?
So obviously, you're saying immutability is important, but of course, if you wanted it to be immutable, you could create setters this way, and at least the point is that it's explicit.
Exactly.
And not happening
so let's
quite
do that.
accidentally.
Let's come back here and say actually age is variable. Age changes over time, and let's say this app's running for a prolonged period of time. We want the same person with a different age. So at that point, when we do our generate person, we add another thing to the public interface. So we add to this a set age, which is a function that goes age is equal to age. So all of a sudden we've added that. If you look at the public interface after generating a person, then we've got a set age, it's explicit, we're deciding what people can do and what they can't. So if you came across that in a code base, what questions would you have about it? What haven't I explained?
Name and age is still not private.
So basically, because they're parameters here, they're passed in, and so once I've passed in that string, I've lost my reference to it. I can't change it. If it happens to be an object, I could change that object because it's the instance that gets passed in. But actually, now that I've pushed that name in, well, it's inside the scope. So, yeah,
Could I have a crack at that?
absolutely.
So, in C and I guess in Java too, you have a stack that gets defined per block.
No, I don't understand why it's done like
Yeah.
that, but it's not like perhaps you're correct when doing it.
So
you correct it and made a slide and stuff.
the what? Sorry, the what? This could change. Or
Yes,
in JavaScript, strings aren't objects in that way. Like in Java, that when you create a string or change a string, it actually generates a new string. So are you saying that if I had Matt's name is Matt, then I generate person, Matt, and I give Matt as a parameter. Is that what you're saying?
Matt's name is a parameter.
Matt's name, yeah, of course. Matt's name.
With an S.
No, fussy that spelling, aren't I?
Oh,
So
mate, it's the
there, the way the JavaScript works, I can then change Matt's name on the outside. And then still ask for Matt.getName, and it will get the correct name. The reason is, sorry, I've realised the settings messed up here. Here, because we're assigning, Matt's name is now equal to this. It's generating a new string. It's changing the assignment, and therefore, actually, what we passed in here is passed by reference. We're not accessing the global variable. So if we were in a setting where there was kind of intentional scope leakage, where there's Matt's name is equal to A, and then some function just do something which then kind of relies on that global thing, Matt's name, then we're opening ourselves up to change. So now if I do something and then change what Matt's name is, and then do it again. So because we're intentionally kind of looking up to the global scope there, we're allowing it to change. But what we're doing in here is containing that scope. Does that make sense?
I think something you can sort of do Matt.name and still add variables.
You can add variables because it's a very free language. You can add as many variables as you want. But the way that we've written these getters, because they're not looking at this, they're not looking at the public interface of this stuff, they're looking at a private set of variables. It doesn't matter what you do to the interface.
So at what point do you do the normal checks, like is available to or typo? Would you be able to use that in this context? You know, to kind of separate it from prototyping, from the object prototyping.
So it's not actually attached to an object prototype at all.
Yeah, what I was going to say was that I can see what you're doing and restricting the ability to change your value of get name, get age functions. You still can make that, say, mat.age equals minus 2.5 and mat.name equals etc. And if you then ask for mat.name, you get back a completely different value. So there's confusion there that means that whoever's using this code, you're right, if someone else is using it, they've got to know exactly what you've done and that they can't just say mat.name equals etc. and get away with it because it looks like they can. Because they can then retrieve it by the standard mechanism.
So, sorry, what you're saying there? So we're talking about this scenario. So Matt is generated as a correct what status. So Matt. Then we're talking about map.name equals separate. And so you're saying that as
You're saying you're adding that value into the object, aren't you?
Yeah. And so you're
if someone could retrieve that value, if someone then came along and said, what's mat.name, not realising they've got to call the function in the name, they'll be thinking that's all working fine.
Absolutely. So that's one of those things that You can do that because JavaScript, you can add any properties to anything. I could go and create an array and add other stuff to it, and because it's free, you can just do anything like that. Therefore, if we document these well and clearly, these interfaces, then we're encouraging people down the line and we're expecting them to go.
I think it's the thing that has to be documented the best way you have to use this.
One of the things we're going to look at next time is unit tests. Unit tests can be a great way of showing someone how they can actually use your code in the proper way. So you can document good examples of how it should be done. Cool. Let's dive on to the next bit. Yeah. A warning about patterns. Someone once said to me, that, not about my code, about a code base we've just adopted. This looks like the code written just after reading a patterns book. There is a big danger when you read a patterns book, you discover some new patterns that you just look for the opportunities to use it. So my request is please don't treat our JavaScript or any other shared code base as a chance to show off how clever you are, because I'm not clever enough to keep up and it will just confuse me. So when we look at these patterns, use them as tools, use them when they come up, but there's no bonus points for filling in as many patterns as possible. So this one, again, I'm looking for some frowns, I'm looking for some blank faces. Let's see. Functions, accepting functions, returning functions. Up here, there's a number comparator. And what we're doing with this is really using the expressiveness of functions. So we're going to unpick this, we're going to look at it piece by piece and come back to it. But this is the end goal here. We create a greater than by using number comparator and giving it the function which is knowing how to actually compare two numbers. So our greater than returns if A is greater than B, and our divisible by returns if the modulo of A and B is 0. So we can then use these here. We find out that 3 is greater than 2, we find out that 4 is divisible by 2, and we find out that string of 1, string of 2 is an error, because they're not numbers, they can't be compared in that way. So with this, we're doing a lot of work with different functions, variables, functions. There's a few things to explain. So we'll go through that and we'll come back to literally this slide in a minute. We talked before about functions for scoping. So you contain private things within functions. These ones here, named functions. Probably the most common one, the most familiar one. You want a function called A? Great, function A. Then got anonymous functions, where there is no name. It basically returns, this statement gives you an instance of a function. It's completely anonymous. I believe that was added to Java 7 recently-ish, having anonymous functions in there. Variables, var A, this function, is an exact equivalent to function A. It just doesn't quite read as nicely.
Except it doesn't say name.
Except it doesn't say name, yes. Any way that you create that function, it can be passed in as a reference to other functions. It can be stored as a variable, all of that stuff. The thing that Adrian mentioned about storing the name, if you want to do recursive function calls, you have to have a name for your function. If it's going to call from inside itself, and therefore that's the only one you can use. With that exception, these are pretty much equivalent. So, what we'll do, are these three types familiar for people? Have you seen them before? Yeah? The functions inside functions might look a bit scary. We've got a parent function, child function, a grandchild function. Now, what this one will do, this grandchild function contains a console log. So we just create that here. I didn't run this one. Oh, it's those things. Okay. So when we run parent, it's telling me it's running grandchild A, B, C. So that means it hit this middle bit, and it's got variables A, B, and C in scope. But if we ask for the child function, then it's just not going to exist. What that allows you to do, this becomes really powerful when you're working with kind of bigger problems. You can break your problem down as much as you want within a private space. So if you've got a function which is, what did I do recently? Prepare data. We get data in from a third party, we need to prepare it so we can render it. And actually that needs to do a load of different things, and each bit's kind of special and kind of complicated. Actually, you can just create a function which is going to be deal with this part, deal with that part, and you can start to break the problem down into smaller parts. And you're not changing the public interface. People still only know the parent function exists. You're dealing with a scope that you're completely free inside this scope to use as many variables and inner functions as you want. The other thing I'm trying to show here is that the variables carry through. So when grandchild asks for A, B, C, it gets parent A, child B, and grandchild C. If we wanted to change that in one particular scope, then we can actually, without using line breaks, say that B is equal to new B. Oh, sorry, var. Forget that one. Now, if we rerun parent, then we've got our new B value here. By using var there, we've said there's a new scope here. That means we're creating a new B, we're not adapting that B. So if child also relied on that behaviour of B, we're not changing it. If we wanted to change it, just take away var and it will look for the next one up. So it's a really powerful mix of things. When you start to get this, you can really break down into granular parts.
Doesn't JSLint not let you, if you're using JSLint, not let you put functions inside of functions?
It does. Oh, this has never stopped me. What JavaScript will stop you from doing is creating a function after it's been used. You have to create it and then initialize it, which goes against Uncle Bob's suggestions. Does that make sense?
Who's Uncle Bob?
Uncle Bob, Robert C. Martin, Mr. Clean Code. I'm a little bit of a fanboy. But depending on whether you know Uncle Bob or whether you know Doug Crockford. Doug Crockford is the Uncle Bob of the JavaScript world, or Uncle Bob is the Doug Crockford of everything else.
Do you actually know either of them?
Sorry?
Do you actually know either of them?
No. But I've watched lots of videos. Proper fanboy. So, functions in more depth. What's the closures, of course. Let's try and work out what the difference was. The power of JavaScript all comes from functions, and therefore the pattern that's come out is using closures to contain the scope. So here there's a function that basically runs itself. So the convention is to wrap it in brackets. There's a disagreement about whether that last bracket should come before or after the end. But basically, if you create a function, let's just make it anonymous, console log found, and after you've done it, what you're going to get out there. Really?
Space.
Space.
Space is alright. Function.
Space there.
Any?
No, it's fine. What have I done wrong? Really?
Is it because you got a line from the first?
That's not. Strange. Alright. I'll name it. Oh, right. Okay. Sorry. Chrome does get a bit fussy about creating anonymous functions without brackets. So I think with brackets that will work. That's the reason why you wrap brackets. Because Chrome started complaining about it. Basically, that's how an instance of a function. So if I do a console log map, I get back that function. Now, if if I want to run that function, then what's happening here is it's logging math and then returning undefined. So there's a massive difference. If I just create a name function, A, in JavaScript there's a massive difference between A and A. This one here is the return value, the value returned by A. That one there is the actual instance itself of A. So when you create an anonymous function, you're doing the equivalent of that. When you then want to initialize it, get the return value, but not care about what the function is called, it doesn't need to live on afterward, then it becomes a closure. So what you do is, so you can create variable, if I just call it ABC, and then, let's just console log. So now, if I look for ABC, it's not defined. We've contained the scope of ABC in here. Now, without closures, you end up having to name your functions, they end up in global space, it all gets a bit awkward. But just having the power to create a function and run it without it ever being logged in is really powerful. So quite often, what you'll do is one of two things. One of three things. Either you'll do something that doesn't need to have any long-lasting footprint, or you'll do something like var_tm, and then your closure will return, after it's set a load of variables, done a load of useful things, it will return an object that then becomes tm. So now when we look at tm, it's there. So you can contain any scope you want inside here, and just like the generate person, you can then return a public interface. Or you can go from the inside of the function and start affecting things in global scope by intentionally using like window docs. So that is tm. Let's use util equals some object. So in any one of those, you've then got kind of something useful happening in a contained scope, and whether or not you want the footprint is your decision. Does that make sense? Lovely. So, let's see. I'm losing track of pages.
Could you explain why some closure has the double parentheses outside closure or why
It's
inside?
two different conventions that came up at about the same time. So it doesn't make any difference at all. What you're saying is create a function and run it. The one that I follow is Doug Crockford's one. I would.
Is something related with browsers, no? If you go to put the parentheses inside or outside, can you?
No, I was wrong the other day. As long as the anonymous function is inside some brackets, you're fine. Coming back now to this one, and this is probably about where we'll call it quits, and we'll come back to the other stuff in the next session. Our number comparator hopefully starts to make a bit more sense now. We're going to accept a method as a parameter. Now down here we're creating anonymous functions, because we don't care about them long term. We could, if we wanted to, turn these into variables and stick that in, or we could have them as named functions and give the instance. Then it returns a function. So that's the step that we haven't gone through here. Because functions are just variables, you can have a string, a function, both assigned to A and B. What we're doing is returning that function. So, for example, so we go var do something useful. We're going to basically create a closure so that we can contain the scope. So again, private is private. Now the return value here, we're going to return a function. Console log accessing private.
Because you have to put it all on one line.
Yeah. Start again. Right. Sorry. So it's going to be there. So let's just check that works. Good.
We're missing. I think we're missing a closing curly brace.
No.
That's what was wrong.
Yeah. We're almost there. So we're going to return a new function, and that function is going to make use of this private scope. So log private is private.
Closing it right click.
There.
Yeah.
Score. Thank you. So now do something useful. What we've got there. Let me bring this into space. I can actually put some line breaks in. I haven't got space. That's what I want. Sorry, everything on my screen's got tiny font.
Just use the console.
The problem is it doesn't like multi-line. There we go.
Just press Shift
Let's
F and
bring
go on to that part.
To do something useful, we're creating a function. Inside that function, we've got a variable, and we're returning a function. Yeah, it's got it. So what we're returning here is a function which can access the private variable. So back to that one. I think I've explained each of the principles step by step. But does that actually make sense? Yeah? So we create a number comparator that does something useful up here, adds some behaviour that we wouldn't want to add to each one of these individually. And when we want to create a new number comparator, we give it the one bit we want to change, the function there that does the comparison. And what we get returned is a new function here.
You're basically decorating a bunch of video.
I think that's probably a good time to call it quits. It's exactly 1 o'clock. There's other examples going through here that I think that if we call it quits there, come back to the other examples this time next week or later in the week or whenever we've got some time, I think it will make more sense than trying to rush through them now.
Sorry, can I ask just one quick question? Only because I completely forgot about it. So in jQuery, you always chain things.
Yeah.
And is this basically an application of that principle, or do they do that slightly?
They do that differently. Essentially, in jQuery, everything returns this. So when you create a new jQuery library, if you don't return this, then people get confused. We're going to dive into jQuery stuff specifically in one of the future sessions. So. I've got some problem-solving examples. I think if anyone's particularly interested in or particularly confused by what we've gone through, then actually going through some of those more one-to-one could be really helpful. So if we get something in the diary for the next group session, but if you've got questions before that, I'm always happy to go through this stuff more individually, and sometimes it just falls into place that way.
Thank you very much, Matt.
Thanks, Matt.
Still recording, Jim?
And I realised there's something that we didn't go into detail on.
Yeah.
And I'm going to save the full detail for another session. But ECMA 5. ECMA 5 adds some power that answers a question that you two had. And basically, ECMA 5, I'll explain when you can use it, how you can use it, restrictions on using it all later. But it's basically the new version of JavaScript. It's the newest specification. So when that's available, you can actually freeze objects. So you create your getters, your setters, all of that, and then you say, right, now, don't let anyone else change it. So I didn't talk about that before because it's not one that I've really played with. But going off and doing some research, there is more stuff that you can do to be more protective over your stuff. So we'll talk in more detail about 8.5 things later. Good thing is, I was looking through the slides, and the things that we've got now coming up should be less mind-blowing, less complicated, and there should actually be really simple things that will help you in your day-to-day JavaScript. So, any questions from last time? Still coming up? No? Cool. Thank you. Let's get this set up properly, and then make a proper start.
Is it in the front?
Brilliant. Should. Okay. Wonderful. Oh, almost wonderful. One step away from wonderful. I showed it full screen on my screen, and now it's dead. Oh, please don't do that to me, Google Docs. Okay. Got it.
Oh,
Wonderful.
wunderbar.
Wunderbar. You get to see all of my bookmark bar as well. So basically, a few little patterns here, and this is probably going to be a bit more quickfire. And I think this time, as I was saying, there should be some really useful things that will hopefully make you feel a lot more confident with JavaScript. Have you seen this before? var a is parent.child // default. Seen it before? Know what it means?
Yeah.
It's a standard OR condition. If we do that and we stick it in an if, then it looks much more at home. How JavaScript deals with OR statements, because it doesn't care too much about the typing of the variables. Like we said before, there's truthy values, there's falsy values, and actually what happens is if parent.child exists, it gets returned from this statement. If it doesn't exist, the OR condition runs, and the return value of the statement is a string. So what this is basically saying is, if parent.child exists, use it. And if it doesn't, do the default. So it's the exact same kind of OR processing as you get in languages like Java and C, all of that stuff. It only runs the conditions it needs to run. And the big difference is the return value isn't a boolean. It's whatever type the correct answer was. So it's exactly the same as writing this. var a. And now if parent.child, so if that's truthy, we'll go into what truthy values are in a bit more detail in a minute, then a is equal to parent.child. Otherwise, a is equal to default. Now that's really simple and really powerful. And that, I'm calling these things JavaScript patterns. It's kind of a micro pattern. It's a tiny little pattern that just keeps things tidier. So, this warning, basically, there is a problem with using this when you're using, let's bring up an example. Here we go. Right. So again, let's go to a nice playground, bounce, blank. So we've got a console up here. So I can do it, if I create a parent, and that's got child, it's A. Console's up. So now I can go var b equals parent.child or default. And the answer, B, is now A, because we set that. But if I look for parent.child.grandchild, then now B is equal to default. So because that one doesn't exist, it falls back to that one. So that's all cool. But if you try and use that without the kind of parent-child relationship, you get a different a different result. So actually, just for speed, instead of storing that as B, you can just remove that and we'll see the return value of that one. So if I go A, in fact, what haven't we used yet? Nothing or default. We get a reference error because nothing actually doesn't exist. So if you remember before, I said that window is exactly the same as looking this up. So nothing is going to give me a reference error, but window.nothing is going to look for the same. It's going to look for the same variable, but if it's not found, it will just give me undefined. So we can actually use window.nothing or default. And if someone does create nothing is equal to something, then what we end up with from that is the something that someone created. So we're just getting past the reference error there. If we didn't want to do that, there is a safe way of checking this stuff. It's the type of. So sorry, if nothing is undefined and we get a reference error, then if we ask for the type of nothing, then we get the string of undefined. So people sometimes get confused about, do you need to use type of or not? And the answer is, if it's just a global scope variable, then you do need to check the type of it to make sure you're safe. But this power comes in if it's a child of something. So window.nothing is a child of window. So it's the same variable but a different syntax. Does that make sense? Lovely. Now there's a similar one here, existence checking. The and, of course, does the opposite of the or. So in this case, if parent.child exists, it will continue on and go parent.child.grandchild. At that point, the return value will be either parent.child or parent.child.grandchild. So it's basically, if parent.child exists, then it will look for the grandchild. If it doesn't, it will just look at the child. Now, that becomes particularly useful. So again, if we just refresh that one and get their parent equals child is A, and then if we look for parent.child, it's going to work. But if we look for parent.grandchild, parent.child.grandchild, it doesn't work. Now, here it's nice and safe, simple, we get an undefined out, it's all good. The problem comes if you ask for something at that higher level that doesn't exist. Because then you're saying, right, look up chi in parent, and now look for the grandchild of it, and what you get is you can't ask for grandchild on undefined. Now that's essentially the same as a null pointer exception, and so a great way of protecting against that is parent.chi and parent.chi.grandchild. So if this comes back as undefined, it never hits the and never hits the second half of it, and actually your return value of that is undefined. And we can deal with an undefined. So if you're not sure that each thing works, that's a nice little syntax for it. And it boils down to being exactly the same as writing an if statement around it. So those two patterns can actually be quite useful, just as little ways of working that.
But in that instance, you're not sure necessarily if you're going to get the child or the grandchild.
Exactly. In this case, if the child... Essentially, this is a pattern for existence checking. So the times when you want to use this is when the parent might be undefined. And at this point, that's exactly the pattern, is that at this point, A will be undefined either if child is undefined or if grandchild is undefined. So then in one go you can say, right, if grandchild, like if that variable A is undefined, then do something else. Does that make sense?
Mm-hmm.
Lovely. So, namespacing. This is one I had to sneak in because I realised at the end of last time we hadn't got it in there. You might have seen stuff like this before. Basically, JavaScript doesn't have any namespacing built into the language, but this is people's way of getting around that. If I create a variable called tm in global scope, and then using a default value of an empty object, actually, if someone's already created tm and they've already added some stuff to it, I'm not going to overwrite it. But if it doesn't exist, I'm safe. If I happen to be the first thing, we're going to create an empty thing. If I happen to be the second thing, I get TM. Then you can build in my project.helper. You can go as deep as you want. And all that this is a map of objects. So if I grab that, which I can't do in presentation mode, let's rewrite it. So let's just get a fresh one. Var TM. So at the moment, TM's not defined. So I define it. TM equals TM or. Now, some people again get confused about, do you need var for the second one? Do I now go my widget or my, what do I call it? I called it my project. So do I go TM my project? And the answer is you don't use a var for this one because actually TM already exists. So you're not creating a new variable. There's no kind of new root object. You're adding to an existing object. So you don't use var. So that one comes in, and then you can build in. Let's just do my thing. Is my. So now if we look at TM, we've got an object with my project and my thing inside it. So you've got that that hierarchy. So now you can play with anything you want in my thing. It is actually global scope still. Everyone can still use it. It's not private, but at least it's kind of contained in the scope. So the naming of it could be relative to my project. So for example, we've got something called most popular inside the context of what's on. Now inside the context of what's on, most popular might mean something completely different to in the context of match center. So just by namespacing it, we can start to get a more granular name going on.
I'm never quite sure with JavaScript. Like in a browser, is it effectively all single-threaded, so that you would never have any kind of raise condition or locking necessary to do that? But then, in all environments, is that true? Essentially,
there's a linear progression to the JavaScript file that you're writing. So whether or not it's running in parallel with other files, unless you start spawning async stuff or click handlers and things like that, you can rely on it running in order. So if the top of your file goes through these steps, it defines TM, it defines my project, it defines that, then you're avoiding the race condition of what if someone else's script ran before mine or after mine. For example, we use the JS minify widget to decide which order it is. If we assumed that the first file was going to create TM, and then we stop using the first file and we take that out of the minify widget, well now that's undefined for everything else. So it's worth being safe, but it's more about which order you're going to initialize things in. You're less likely to be creating this stuff in an async.
I guess I was thinking even at the level of a simple statement, is like var tm equals tm pipe brace. Is that always safe? In the sense that, like...
Will something else run while that line's executing?
Yeah.
Yes, it is. Yeah, so you don't need the mutex or something like that.
Yeah, I guess that's right. But is that true in server-side environments too?
Yeah.
Okay.
So even in Node.js, JavaScript is completely single-threaded.
Yeah.
And so you can start new processes which would then have a completely different memory space. But because of being single-threaded,
so each process wouldn't be interacting at this level with another process, but okay, and then it's single-threaded within the process.
Yeah.
Okay.
What you do get in JavaScript, and particularly we're going to look at it next session in I'm calling real-world JavaScript, which looks at things like in the browser and stuff. You do get click handlers that fire at unpredictable times. So standing here saying it's single-threaded might sound contradictory to what I'll be saying next time, but actually the order of execution in some things, like click handlers, timeouts, you need to be ready for it to come in at any moment, but it's still a single-threaded environment.
There's a difference between not knowing the order and it literally having
exactly. And essentially with JavaScript, it's about not knowing the order rather than having actual multi-threaded most of the time.
I was going to say, this would be the kind of pattern you would use if you were using console.logs and you wanted to pipe it through JS-lint. Is that? Because if you were using console.log and JS-lint would say console was undefined.
Yeah.
This is kind of what you would do to overcome that.
It's one way of overcoming it, but I'm going to suggest a different way. Probably in next week's session.
So sorry.
Yeah.
just another thing to add to this. Like the event loop will also execute an entire function at a time. It will never schedule out to a different function without completing one function.
Okay.
That's also handy.
So it's unpredictable single-threadedness rather than
yes.
actual. Yeah. Cool. But in this sort of thing, it's pretty predictable. Reflection. Reflection is actually really simple in JavaScript. We've got a container where A is equal to A, B is equal to B, and C is equal to C. Container.A is exactly the same as container, and then looking like it's looking at a string of A in an array. These are exactly equivalent syntaxes. The reason for this second one to exist is so that you can use reflection, so that you can start to variabilize what A is. So, for example,
also, can't you have the property name having spaces in the name, but you'd have to use the square bracket syntax, surely?
Yeah, and we'll come on to that later, actually. So, if we go container equals so A is A, so simplify it to B is B. Then, if we look up container.A, is that container A is that. But it means that then what we can do is, let's say, create a function, just look up. So we can get the index, and thanks to Tim, I can now press enter, shift enter. And so you can return container index. So that actually knowing which index it is, we can do that one. So look up A is going to work, look up B. So you've got that simple difference actually enables quite a lot of reflection style things to go on, and actually there are rules about what characters can and can't go after this. So like spaces, dots, can't have any of that, but you can put it all into here. Now I said before, right at the beginning, that objects and arrays are confusingly similar and different. Both of these work for both objects and arrays. So you don't need to worry about which type it is. But the convention is, if you're accessing it by name, like by key value pairs, use an object. If you're accessing it by ordered indexes, use an array. And if there's a good reason to, I'll go into more detail than that. But that general rule should keep you safe for a lot of the things. There is an example. I'm trying to remember what my example was now. I planned to do this on Monday. I was all ready for that. I can't say it. I'm going to have to show it to you at the same time. Right, that was it. So console log ABC is exactly the same as console log ABC. So I think we'll dig into that a little bit here. I think it was here, not later. That was it. Yeah. So if we wanted to create something using the last 3 or 4 patterns that we've just looked at, to create a safe logger. So this kind of answers Tim's thing about JSMint to an extent. I'll answer the other half later. In some browsers, console doesn't exist. In other browsers, it does exist and doesn't have debug, but it does have log or it does have other stuff. And so now, modern browsers support console, which has error and warn and info and all sorts of useful stuff, but old browsers don't. Now, it tends to be that people ignore that they try and avoid putting things into the console in case it breaks old browsers. So this is one really simple way of getting around that. The safe log takes a level and a message. And the first thing it does is check whether the level exists. If that level exists, so console.debug, if that exists in this browser, it will then move on to this one, console.debug message. So all of a sudden we've got some power there by mixing together those last few. Any questions about that? Does that make...
Do you not have to do... Why don't you have to do console and then console square brackets level?
A good question, because I was writing this on a plane and didn't think of that.
So you should do that, though.
Actually, if you want to be properly safe, yes, you should. And I've called this safe log, so I should be
Safe-ish log.
Safe-ish, yeah. So I either need to rename my function to safe-ish log or test for console.
This will break on IE, annoyingly.
Yeah.
But would it break if you put the console in too?
No.
No.
Okay, good.
You
But
just not log.
okay, so when you do that, of course, you'll have to do type of console or window.console. Because if you just go console and,
Yeah.
it'll work fine in Chrome, you hit IE8, and you'll get a reference error because console doesn't exist, if you remember back to...
Yeah.
So, I will send these slides around. I thought it was better to keep them together and send them round all together from the two sessions. So, that's the kind of reflection way of doing it. There is a really, really cool thing. Just call and apply. I just thought there was a slide before this.
Calling is cool.
Calling is cool. Sorry, I thought there was a... Right. No. Call and apply are two different ways of running functions, and they are really, really cool. Basically, what you can do, you can have a debug log that looks up a log function. I thought this was coming in later. I'm actually going to come back to it because it goes into a bit more depth than I want to go into right now. First, I'd rather look at updating prototypes. So, this is an example of looping through an array in JavaScript. It's horrible. To loop through an array, one thing you have to do that's unexpected sometimes is look to see whether this array actually has the property that we've just gone through. The reason is that you can inherit from other things, prototypes, and generally when you want to look through this array, you don't care if someone's added a function to the thing that it's inheriting from. You care what values came in here. So JSLint that we've talked about, that kind of is a really good safety net for JavaScript. It actually throws, it fails it if your for doesn't have an if statement. So it's that level of problem. Now, what's happened here is that we've kind of exposed some of the horribleness of the language into a kind of an anti-pattern. It's something that appears all over the place, and JavaScript developers just get used to writing it, and everyone else looks at it and frowns and tries to work out what's going on. So, if we decide that across our code base we don't want this stuff propagating everywhere, we can say, right, array, part of the prototype of array should be an each. So this each function should take a callback. So we'll conceal all of this horribleness inside the array prototype. So then to use that, I think I've got an example. No, I haven't got an example. To use this, what we do is... I'm wishing I could copy and paste. Let me...
That's good.
So let's go for array.prototype.each is a function. So it takes a callback, and
Shift return.
For I in this, I'm actually going to, for the sake of quickness, miss out the if condition, because it won't affect us in this one example, but it would cause us pain in other examples. So call back this I. So what we're doing is looking up the index in whatever array we've been given. So now what we can do is go A, B, C, dot each, give that function that takes the item. And then we can do something like console.log the item. So now, what's that done? Really? I need to return undefined there. Do I? Sorry. Well, that's a really good example. That fourth item in the array is because I didn't have my if has own property.
Yeah.
So if I come back to here and go... if this dot has own property I, because I've added something to the array prototype, it's now part of it. So if I do that again, there we go. So I've given it an array of ABC. I've said for each one, do a console log with that particular item, and we get out ABC. So that means, now that we've dealt with this once in our code base, we don't get all of this stuff. We don't get all of this stuff every time we want to go through an array. Instead, we get a much more manageable something.each. So what I said at the beginning was that JavaScript is missing some really important functions, but we've got the power to add them. This all comes with a warning. Global prototypes are global. If we want to add this, we're adding it for everything. We're even adding it to third parties' libraries. We're doing all of that stuff. So if I'm writing a library, let's say, and I create this function, and you use my library, you're using my each method. All of your arrays will be decorated with it. And if you've not done that check, it'll influence your stuff. So it's really powerful and really useful, but don't take it too lightly. So a couple more really good examples.
So the global nature of it, then what stops somebody else, creating their own each, and they do that after yours, and they said theirs has got a bug in it?
You'll know the answer you'll absolutely hate? Nothing.
I didn't think that was.
Again, with the ECMA 5, you can say no one can change anything here, but you probably don't want to do that on an array prototype, because
put a namespace in your prototype there, so you can make sure that no one's going to reuse that.
Yeah, and there's a general way this stuff works. There's a library that's really useful called underscore, and they've made the decision to not change any object prototypes. What they do is they've got an underscore in global namespace that has all of this stuff on. So you go underscore.each, and then you give that the array and then the function. Problem is it doesn't look very object-oriented. And so you kind of lose all of that object-oriented expressiveness in favour of safety.
So I thought you were suggesting that we use underscore.
I am. Underscore has made the right decision. They aren't imposing on us that we have to add it to the prototype. What I'm actually going to suggest when it comes to it is that we use underscore, and then we do lots of little hooks like this. So that being our own implementation, that passes on to underscore.each. But it's on our array prototype. So we've got .each on the prototype, but we're learning from underscore's way of doing it. Yeah?
I think something quite useful at this point would also to say why you don't, because you can use the old-fashioned for loop. We just go for I equals 0, I smaller than array.length, I++. And then you don't have to do as own property.
Yeah.
But then you assume a lot of stuff.
You assume a lot of stuff, and if someone creates an array, creates 5 things and deletes one of them, you'll get undefined in the middle of that. So there's all of those sort of things that basically, I reckon if we do our jobs right, then every day we're not coding around all of those little weirdnesses in the language. Every day we're dealing with this sort of thing that behaves exactly like we'd expect. Every day we use .each, and it's not every day that we change what .each does. Does that make sense? Any other questions on that? 2 really simple examples. Probably should start with the simple ones. Matching the start of a string in JavaScript looks like this. You get a string, index of whatever is equal to 0, just like it would be in Java. So how about adding this to the string prototype? Starts with, which basically does that. I've added one thing in here, which is if the string length is greater than 0, because otherwise it actually returns true if you give it an empty string. So if we wanted to, we could add this, and therefore we can go, right, that URL, if it starts with HTTP, do this. And suddenly we've got a bit more power, it's a bit more readable, rather than always coding in this stuff. The usage of that becomes ABC starts with A, as opposed to that. The end of a string, exactly the same principle. We can go abc.ends with C, and we use this.
And these prototypes, adding in, updating prototypes.
Yeah.
I mean, with defining them, would you put that in that core .js file?
I would. We've got a file called helpers.js, which is brand new, and it's included on every page of our website. Just like the prototype stuff, we don't want to put too much stuff in there, we don't want to go crazy with it, but anything that's actually really going to be helpful for everything, well, great.
Well, helpers.js is included by core, is it?
Included in core.
Yeah, okay.
And so basically, if we decide that these 2 functions are going to save us a load of hassle in a load of places, then today we can go back and put that in helpers.js, and from that point we can use .startswith and .ends with on any string on our site. That's what I love JavaScript for. That's what I love JavaScript for. It's missing those functions. It should really have them, but we've got the power to add it. Cool? There's a warning. There's always a warning, isn't there? Editing the prototype of a string, object, array, etc., anything, but those are the common ones that you want to be careful of, will affect all instances everywhere. So we create an array. Then after we've created it, we create a log yourself function. Which basically says go through all your stuff and so just log whatever your own value is. Then this array that we create up here, we tell it to log itself. It will and it will use this implementation. And that is good. But it's scary if you don't expect it to happen. Okay? Cool? Oh, wonderful, we got to the end. But we did skip one thing. So, call and apply. Call and apply take a little bit of explanation, but they are really, really powerful and worth it. The example I gave of the log is kind of not as helpful as it could be. If I do a console.log, it works in a kind of printf style. So if we go ABC, $s, DEF, and then we give it a second parameter, which is 1, 2, 3, then it's going to insert that in. And that can be really, really handy when you're doing a log message and you want these following variables in there and whatever. Now, my safe logger I wrote doesn't do that. It takes one parameter that's a message and it passes on that one parameter message. So how do we deal with that? So in Java, you've got an interface where you can have the triple dot inside the argument list and basically say all the rest of the arguments are going to be known as this. Now, JavaScript doesn't really have an equivalent of that, but it does have the same power. Let's go function mapped, and what function mapped's going to do is console.log arguments. Now arguments, I've not created it, it's an assumed variable. So map A, so we've got A, map A, B. So whatever arguments I give it, it knows them under the arguments object. The most horrible thing in dealing with arguments is that arguments is not an array. It's an array-like object. And I'll go into some details about that in a minute. But forgetting about that for a minute, if we want to change the function map so it will actually pass on to the logger. So this is now going to be our safe. Let's change the name of it. This is our safe debug. Sorry, it's debug log. I've called it over here. Let's just use that one. Debug log. I won't actually bother with writing the. I won't bother with writing the bits that make it safe because I'm in Chrome. I'll just carry on. So what we're going to do is var log. Let's call it debug. Equals console.debug. Now, what we can do here is debug.apply. Apply and call both take the first parameter, which is the this value. Do you remember right back at the beginning when we talked about person object? I said that you don't want to rely on this because people can change it. So this is the other way that you can affect it. So in this case, this is console, and the arguments we want to give it are all of the arguments we've been given. So now, debug log A, B. And it's going to log A, B. If we give it %s, see? You can see that it's passing all the properties straight on to the logger. Now this is really powerful. There was one place I worked where there was a version of Firefox that came out that didn't like it if any one of these parameters in the logger was undefined. So what do? We got logs everywhere. So how are we going to do this? So what we did was created pretty much this. We created our own logger that took a debug, a level at the beginning, and then it passed through all of the arguments except the first one. So you can play with this array, you can pass it in, you can do whatever. And then, just before it went in, it looked through that array and made sure nothing was undefined. And if it was, it did kind of exclamation mark, undefined as a string, or something like that, just to say, right, this is undefined, but I can't actually pass it through like that. So that gives you a whole load of power, because you can start using, again, I mentioned reflection before, you can start doing really cool reflection-y things by passing through a kind of unknown list of arguments, just kind of blindly passing it. Now, the difference between call and apply is really simple. If I go, the warning here, console.log.apply. It's quite common to give null as that first parameter. The problem with that is if you do it on something like console, it doesn't. Let's just check that is the reason. No, I've got something wrong there. Apply. Sorry, I know why. So that one works. Let's just clear that. So that one works, but if we didn't specify console, we just give it any object, it's an illegal invocation. Basically, because this becomes the this value, and we'll dig into that a bit more another time. You need, in this case, you need to go console.log needs to work on console. In fact, let's dig into it. Function person, and then, in fact, no, that's not even. Yeah, function get name. Get name from person. And what that does is return this .name. So right back at the beginning, we looked at a getName function. The other use of this stuff, the reason why it has that interface, is because you can give it any object here. So name is equal to Matt. Screw it. I am going to save this for another one and give it a better presentation. So otherwise, I will confuse you more than I help. The arguments thing, I've got a suggestion for this. To turn arguments into an actual array, so you can actually deal with it properly, it's this line. If you Google that line, it will be on thousands of websites and thousands of places. It's a great chance to use namespaces and helpers. We can use a tm.toArray, which encapsulates that. And then in any function that we need to turn the argument array into an array, we go tm.toArray arguments. And suddenly we've got our own function to deal with that. It's namespace.
What is arguments then? If it's
arguments is an array-like object.
But we can't add a toArray method to that.
No, because it's a plain object, I believe. I believe it doesn't have a prototype that can be edited. I can go and look into that.
I don't know.
I think it's generated as a plain object every time, and therefore there's no prototype to look into.
Is that part of the function object? It comes with the function, yeah.
Yeah.
So arguments and apply. Well, you have the arguments and then you have the apply method.
Yes. And that's something worth mentioning. Call and apply exist on all functions everywhere. So console log or any function you create or whatever. It's all got call and apply. And there's some really, really fancy things you can do with it. That, to be honest, if you want to know more about call and apply, it's probably best that a small group to sit down and look at it in detail. But let's jump back to the end. And we have a Q&A. And then if there's still time after questions, I've got a couple of examples I'd like to go through. Any questions?
Just one more common thing you can do with call and apply is to sort of cherry pick a function from one prototype and apply it to a completely different object.
Absolutely. And it's particularly handy if that, like in the log example, if that object on that other prototype needs arguments in a particular order or needs some special thing, then you can kind of pair it much more dynamically and then pass it through. I forgot to say the one important thing is where we call and apply. The reason there's two different things, call takes the arguments as arguments and apply takes all of the arguments as one array. So if you want more detail on that.
Yeah, I just wondered if you could say something more about prototype.
Yes. I kind of skimmed over it, didn't I?
Yeah.
Prototype is special. prototypical inheritance is odd if you're not used to it. I will prepare something nice and ordered for the next one, unless you've got something you want to input.
I think something that made it sort of very clear for me was just the one line that shows inheritance in JavaScript, where you say thing.prototype equals new other thing, and that's how you extend. And that, I don't know, that sort of makes it all.
So basically, prototypes are the closest thing we have to classes in JavaScript. Prototype is kind of the lifeblood of all of that stuff. If you want to say that every function should be able to, I don't know, should have a particular property, or it should do a particular thing, there's the prototype of function that you add that to. And it's like every time you generate a new function, then it's as though you're calling a new function, and you get everything back from the class of function. So you can inherit between prototypes. You can grab things off one prototype and stick them on another. So if in some browsers array has an index of, an object doesn't, so you can grab array's index of and stick it on objects, and it's the prototypes that you're dealing with at that stage. Generally, the level of detail I've gone into at the moment with prototypes is the only level of detail you actually play with, but the understanding behind it would be good to dig into that a bit further. So I've prepared some examples of that. When I say I've prepared some examples, it means if I say something, it'll probably be wrong. So I'd rather not get it wrong right now. That's so. Let's dive into a couple of quick exercises. First of all, code quality principles. If you want to know about my code quality principles, you can search Stuart Digital.
Is this an advert now?
It is. Basically, I have four principles that fit together that I think solve a lot of problems.
Stuart Digital Coding Quality.
And if you want to disagree with me on them, that's fine. I've changed them recently. But they are test-driven development, they're in order, test-driven development, followed by dry, don't repeat yourself, followed by YAGMI, you ain't going to need it, followed by single responsibility principle. So, the reason I mention those...
I've never heard you mention any of them before.
Really? We did have a sprint planning yesterday. We did have Rick saying, "Is this one you mentioned about single responsibility principle for?" Yes, that's it. So, some really simple things that we can go through. Key value cache generator. I'm actually going to change that to kind of a config generator that basically we've got something on our site now that works pretty much like this. I was a bit ambitious with the font size, wasn't I? Let's go down a bit. 28. Let's go down to 6 inch. Okay, so first of all, you create a new config, jsconfig.new, and then config.set A, set it to B, and then we can expect that getting A is going to be equal to B. Sounds pretty simple. We set A.B, and it should come back as, we set that value to C, and it comes back as C. So I've got this running, but it's probably simpler with 10 minutes to go to ignore the test framework and do stuff ourselves, because otherwise I'll have to explain why, and that'll be 10 minutes, and then we won't get any code examples. So, jsconfig.new doesn't exist. So, given that it's only 10 minutes, I'm going to...
What's the point in it? Which is the accidental.
Sorry?
I wonder if you were making a point that JS-config doesn't exist. You just mean it's annoying that it doesn't exist.
Sorry.
Spending time just ignoring.
That's all right. This is the attitude of TDD. Okay.
Oh, I see.
We want to do something. We want to do this, but it doesn't work yet. So we've got to make that work.
Yeah.
Okay. So the simplest way we can make that work is create a var JS-config which has a new function. So at that point, that thing's going to work. So that's cool. Unfortunately, new now needs to return stuff. It's going to get too big too quickly. We're going to need this. That's the one.
This is one I made earlier.
Yeah, no, I was going to do the one I made earlier, and I realised it wasn't actually going to be the most helpful thing. So I tried to do something more helpful. There's one I made earlier. Okay. So there is an actual failing test, and the source code for it is up here. So let's have a look at that. Cool. All right. Yeah, this is going to be the easiest way. So the source JS config. Have we done TDD before? Have you seen TDD before? Have you experienced TDD? Have you fallen in love with TDD? Have you fallen out of love with it? Have you,
Maybe both.
both. Good. That's usually the process. Have you gone back to falling in love with it again? So here we've got a failing test saying that JS config doesn't exist. In JavaScript, the way of creating that is really simple. Now it's going to be, there's no new method of undefined. So great. Let's create that with a new, which is a function. And at that point, there's no set on the return value. So if we look back at the test here, we're expecting that thing when we've got new there, it's coming back as conf, and we're expecting to set something on conf. So that new function needs to return object which has a set. So now it doesn't have a get. Let's create a get. Now it expects undefined to be B. So the thing that scares people who don't do TDD very often, turn B. Now we've got the simplest thing that could possibly pass our tests. Each of those, each of those steps there should make sense to you. Do that. I've rushed it, but does that make sense? You know why that works. We pull that one up at the same time. We've got our test here. Oops. Our test here creates new, and what it gets returned is a new object here. And then when we set that, we can get stuff back. Okay. What we're going to need to do is include the next test. So in this particular test runner, you can call test exit to close them out. So now the next test is going to fail. Expect a B to be C. All right. So there's a reason for that. So it's setting values. So how can we persist a value between the getter and the setter? You should have the tools to do this. Any answers?
Obviously, put it in the global scope.
Put it in the global scope. Let's do it. Let's do it. Okay. So what we're going to do is var. Oh no, not with var. We're going to go window.value equals right, and this is going to be key and value. Window.value equals whatever value we get. Okay. So now here we can return window.value.
Hang on, window.key equals value?
Who cares? It's there. Window.value. Let's rename that. Let's call it temp, because all we care about is this one thing. Okay, so window.temp equals whatever value it is. Okay, so what I'm going to have to do now, this is a usage examples JS, and it would be wrong to put the next test in there. So I'm going to go into misc tests. I'm just going to create describe annoying mic. I've got to write a failing test for this. So what I'm going to do is
it's annoying that you've misspelled it, yeah.
Sorry, how have I done it? It's true irony, isn't it? True irony. Okay. So how am I going to do this? It should not store temp value in global space. function, and then we're going to go jsconfig.new.set a is b, and we're going to expect window.temp to be undefined. Okay.
Oh, I might not have called it temp though.
If you start calling other things, but for the purposes of speed, I won't play what I consider what I like to call TDD chess with Mick, where you're kind of thinking 2 moves ahead. And, right. So now we've got a failing test because it's exposing something in global scope that shouldn't be. So how can we take that out of global scope and keep it working? This, okay. So this .temp is gonna work. Oops.
Not like that.
I need a return. There you go. Spent a few months writing Ruby where you don't need return statements, and then wondering why none of my JavaScript worked because I wasn't using return statements. So okay, now we've taken it out of global scope. It works. I've got no reason to disagree with that because it passes all the tests. So the next test, let's have a look. It should gracefully deal with unknown properties. And it already does. So what we're expecting here is get unknown to be undefined. So because we haven't set anything, it already works. So that's cool, that's fine. Next test, let's have a look. That one works as well. It should gracefully deal with unknown hierarchical properties. That's fine. So if we say a.b and a doesn't exist, then it shouldn't fail with that. So this is basically my dream config.
Definitely should have been square brackets. Quite.
So the next one passes as well. Should not leak data between instances. It already does that. So if I set ab in a config and then create a new config and get ab, it should be undefined. So good, it ticks that box. I think this one's going to fail. This one is going to fail. These are set default. Okay. So what I'm going to do, simplest possible way of fixing that.
So you just value equals.
At the moment, we don't know that it needs to do anything. So there's a function, it will keep it happy, it will work. We'll see if there's another problem. Expected undefined to be B. So why don't we just pass on, this takes key and value. Why don't we just go this.set key value? Because it looks like it needs to just behave in the same way. It's fine. This is where we could use apply if we wanted. So we can go this.set.apply, and we can just pass all of the arguments straight through. So we don't need to worry about if that interface changes. This is the subject, and then all of the arguments, and it's still going to pass. So our time's up there, but what we've started to do here is to create, basically we've done all of these things. We're storing and receiving symbol properties, we're separating them with dots, and that's all fine because we're not actually using a key at the moment. I'm sure. Let's come to one where. Have I not got a test in here that's the key needs to get changed? I haven't. I'm going to write one because I'd like to just deal with it. Now we're out of time.
You've got minus 30 seconds.
Minus 30 seconds. Okay. This is something that I believe we can actually use. I've written these tests as a chance to kind of go through this stuff. If you're interested in carrying on with this, I'm all up for that in another lunch break or something. Probably not with everyone. Probably not everyone's interested. But this is an open source JS config that is on GitHub. You can check out the source. And as long as no one in management complains at me, I checked with Ed. Ed seems happy with it. We can create this as an open source thing. We can release it. We can use it. We can use it as a chance to learn. So this is particularly useful if you want to see how unit tests work in JavaScript. We're going to go through a few more examples kind of like this, but if you want the deeper level, if you want how to write the tests, if you want all that stuff, very happy to do a group of people who are interested. Do a session for a group of people who are interested in that rather than insisting on Does that help?
That's great. Thank you very much again.
Cool.
Thank you.
Thank you.